Have you ever wondered what's behind all of these products that help save our skin? It seems that they all have one thing in common. Salicylic acid.
Carboxylic acids are a big part of teenage and young adult life in the form of salicylic acid, a carboxylic acid that helps shedding of dead skin cells to unclog pores and help treat and prevent acne. This product is widely used in face washes and acne treatment products such as Neutrogena and Clean and Clear. The general form of a carboxylic acid is a hydrocarbon attached to a carboxyl group. A carboxyl group is shown on the top picture here. Naming carboxylic acids according to IUPAC is identifying the parent chain. The parent chain in a carboxylic acid is the longest continuous carbon chain that includes the carboxyl group. So in this example, this would be the longest carbon chain, and this would be the carboxyl group. Numbering begins at the carbonyl carbon as carbon number 1, and we are only numbering the carbons. The carbonyl carbon is shown in the bottom picture. To name carboxylic acid parent chains, drop the E off the end of the alkane name and add oic acid. For example, we have the alkane butane. Butane, we're naming the parent chain, which is the longest continuous chain of carbons. So this would be 1, 2, 3, and 4, which would result in but if we look at the prefixes for naming organic compounds, which would be butane, and that corresponds to the carboxylic acid, which is naming the parent chain as well, which starts with the carbonyl carbon, which is this carbon, which is 1, 2, 3, 4, which is but. We drop the E off the alkane name and add oic acid for butanoic acid. Any alkyl groups attached to the parent chain need to be named by the position, number of appearances, and the alkyl name. To name any alkyl substituents, we follow this chart. For an example, we've had this carboxylic acid up here. And we're going to start it the same as we did the last one with the parent chain, which is the longest chain of continuous carbons containing the carboxyl group. We start at the carbonyl carbon, which is carbon number 1, 2, 3, 4, and 5. So for this one, we have a 5-chain parent chain, which means that it is going to be called pentanoic acid. And the second step is identifying any alkyl groups in this example, and there is a methyl group attached to the carbon number 4. This represents a methyl if we looked back to our chart that I just provided you. Third step, put the position and number of appearances of alkyl before its name, followed by the parent chain name. So for our example, we would put 4 methyl, because this is a methyl group on carbon number 4. pentanoic acid because we dropped the E from the pentane name and we added oic acid for 4-methylpentanoic acid. If there are multiple of the same substituent group attached to the parent chain, we would name it in numerical order and give it an alkyl prefix. So for this one, for naming it, we still name the parent chain, starting with the longest carbonyl chain of continuous carbons with the carboxyl group. Starting at the carbonyl carbon 1, 2, 3, 4, 5, 6. And noticing that we have 2 of the same substituent groups, which happen to be ethyl groups. And since there are 2 of the same, we would put di in front of our alkyl name. So for naming this, it would be 3, 4 diethyl hexanoic acid. Because hexane is the parent chain, we dropped the E from the alkane name, adding oic acid. We added the di for both of our ethyl groups, which are on 3 and 4, being 3,4-diethyl hexanoic acid. So the answer to number 1 would be this structure right here, because if we start numbering at the carboxyl group, right here is carbonyl number 1, carbonyl number 2, carbonyl number 3, carbon number 4, carbon number 5, carbon number 6, carbon number 7, which is heptanoic acid. And then the answer for number 2 would be 5-propyl octanoic acid, because we have a propyl group right here as a substituent, which is on carbon number 5. Carbon number 1, 2, 3, 4, 5, 6, 7, 8, which is where we get oct, and propyl is this group right here for 5-propyl octanoic acid.